Ingersoll-rand. This is a 30 horsepower rotary screw compressor. That means that it's a helical rotary compressor, oil flooded, positive displacement. We're going to go through some of the fundamentals of this machine. Refrigerated dryer, take care of the dew point down to about 34 degrees, which means that you will not have any water in your lines unless that line hits outside air at below 34 degrees. You have a dew point indicator right here. We'd like to see that always in the green. Right now it's off, so it's at ambient temperature. Your control panel, I haven't been told what your pressure settings are, but I have this set up for 100 psi to maintain and 110 to shut off. This is probably different than what you're used to. This is a variable speed unit. You have one that's a variable speed, which means it's not an on and off line. It's a target pressure. It's going to try and maintain that pressure for you. Right now, like I said, it's at 100 psi. Inside this cabinet, we'll go to this side right here. The drive is right here. Your inside the cabinet, you have your incoming power, your starter for your blower, and your solid-state relays to control different aspects of the compressor. This is your dryer control panel. Basically, it's totally automatic. You don't have to touch that whatsoever. You have two filters right here. You have a general purpose, which is going to catch the large stuff, and then you have a HE filter, which is your high efficient, which is going to catch the small stuff coming out of the system. And they also put in an absorption filter right here, which is going to catch smells. Any kind of smell that goes through is supposed to absorb. Well, that's what that little thing right there is supposed to be. It looks like someone popped it when they installed it, so it's kind of timing out. But basically, you can go by the hours of use on the machine. You know, whichever machine is on, you kind of go by them. We're starting at 0. We like to see those changed out every year, but if it's only got 1,000 hours on the unit, that's not a lot of time, so you can probably get 2 years of use out of it. But you do want to check those. We're going to get to that and kind of give it a check. If you open them up, make sure that the pressure's off of them, obviously. And you can open them up, look at the physical condition of them. You know, if it looks like it's saturated, or if you look down inside the filter itself, there's a lot of particulates or something like that, you might want to change it. All right. Well, like I said, your control panel's right here. This is your first window. This is the one that it always we'll try and go back to. This is going to show you your pressure, the setting. Right now it's set for 100. If you increment it, use the down arrows, you're going to start getting different graphs. This is the first window. The second one's, the only thing that changed is RPMs and savings. Right now we don't have it hooked or set up for your savings for power, because I don't know what your cost per kilowatt is. I'd have to know. Is it 6 cents? All right. Then we'll do that when we go through this. If you guys want to change your pressures and all that stuff, you got your target pressure. You can do this on the fly also. It's basically saying target pressure. You say, it says press OK to change. All right. Now if I wanted to go to 110, I could sidestep. Right. Go to 110. OK. And it's done. If I didn't want that.
What stops you from being able to accidentally hit an extra 0 or something to make, like...
You can't. Right. It's a rated pressure. It's only rated to 150. Maximum pressure 160. You can't
just
go
I can see if you can see.
No, you can't go to 1,000.
I'm make 1,000 blow thing up.
Yeah, it's not going to happen.
Let me ask this question. Is there a way to lock the panel to keep prying fingers from changing anything?
No. That if it reaches that pressure, this is going to wind down to about 25%. All right. If it continues to build pressure and it gets to 110, it will just stop. It'll wait until the pressure drops down to under 100. It'll restart, come back up.
Does it restart fully and then come back, or does it come up slowly?
It'll come, well, this one, it kind of goes like about 50%, then it kind of just winds itself. It determines what it needs at any time.
Looks like you're back to your home screen.
Yeah, it'll time back out and do that. That's what you want. You want to see what the pressure is all the time. So when you come around the corner, which one am I, I got to find out what it is.
You can set it right on the display.
Okay, energy saving. This is like if you wanted to chart how much energy savings, you could do that right. You could do it right here. If you came in monthly and you said, okay, how much did we spend? You go to that savings screen back in the first one, and you write down how much it cost in that month and how much total it cost, because that's a running total for its life. And you write that. Then right here, you come in here and say, okay. All right, you go.
It's based on a variable versus non-variable type of thing?
No, it's based on your kilowatts. How many kilowatts per hour is it saving you versus, let's say versus a regular load and unload type of rotary compressor.
So yes.
You got your date and all that stuff. We've already set that up. Okay, your energy rate, you said 6 cents, right?
Yeah.
All right, so there's your 6 cents per kilowatt. All right, so I can go back here to my energy rate savings. All right, now I select it. I said, yes, I want to reset it. Now I just reset it. So now if I come back here, you see there's lifetime savings, and then there's savings. Those are those two variables. If there was any time there before, it would have been erased. All right, that one would have been a running total.
Okay.
That one you cannot erase. All right, and then back here is the service information. It says it's a 30 horsepower machine. The serial number on the PSD. Intercooler pressure. Dryer discharge pressure, pressure drop. Immediate stop is 140. That means if someone closes that service valve real quick,
Yeah.
and it shoots up, which it can't, because it's kind of like a
But when it gets to
capacitor.
140, it's going to.
It shuts off. Maintenance timer. If you go back to the first screen, you notice that bar, right? It's 0 to 100%. That's going to start counting down. That's why it's got the wrench right there. It's counting down. For your inner. Well, you're going to have your hours right there.
Okay.
All right. All right, and then there's also factory set points, which you're not getting into. I mean, I use them when I come in and do my maintenance. There's the DC bus voltage. There's the amperage from for the drive and all that stuff. All that information's in the factory set point. Right? So that's.
Now,
we'll go in a little bit more on that.
Is it just the down arrow to go through the other screen?
Yeah. I mean, the down arrows, once you're in the screen, you go like this, that gets you into that screen,
Right.
And now you just do the up and down arrows to get to where you
And
want
that
to be.
changes your display. Okay.
Yes. And then it'll always say, if you can change it, you could always say, it'll say, press OK to change. All right? If it's not something you can change,
It won't say that.
it won't say that. Obviously, see, now you're in that, you can't change anything. So
But if I wanted to see the other screens here, I just hit the down arrow.
well, in this
Right.
page, or in this folder, if you will. Think of these as folders.
Okay.
All right, and then you're going through the pages in that folder.
Yeah. Okay. So it comes back to me. Okay. And that's your number.
Yep.
9040. Okay.
Well, that's the air center's number, so you
Right.
get somebody, and you get it 24 hours a day. We're on call 24 hours a day.
24/7.
Yes. E-stop, please keep your hand off of that unless someone's hand is getting chopped off or something is burning or something, because you can make a mess if you bang it. Stop, start. That's what you should be using. All right, so basically you have your condenser, evaporator, your two filters, your compressors in the back there, and your condenser fan. You have your electronic drain valve, which is collecting all the condensate from everything in this machine. All right, you have your two filters, and then you have your moisture separator on the other side coming into this block, and then it discharges on the other side there, or in place. Otherwise, air is just going to be coming out here. You could cause an overheat. You want to make sure. This compartment is your motor compartment. If you notice, you have a little beige colored attachment here. This is an externally mounted blower. It's a cooling fan for the motor for this size unit. 30 and 40 horsepowers have to have this externally mounted blower on it for a little bit added coolant, or cooling, excuse me. Only has one bearing in here. All right, the other bearing is part of the air end. This motor is attached directly to the shaft of the air end. So you have one bearing that's inside of here. It is a serviceable part. So you need to take this blower off and inspect that to make sure right around 8,000 hours you want to be starting to take this apart and checking that.
What are you looking for?
You want to see if the seal is still intact. Are you starting to get some like black debris in there? Because it's a sealed bearing. It's got grease, but it's going to migrate out of it over time, and it will self-destruct.
It shuts down. Does it tell you that you get a
It'll
fault?
tell you the faults that are on here. Yeah, you have your drive faults. Could be DC bus, something like that. But as far as the machine overall has, you're gonna get a high temperature fault. But that's got 3 different points that it's looking at. It's looking at the dryer. It's looking at the temperature of the motor. It's looking at your coolant. So you get a high temperature fault, A202. You might be looking, at high temperature of the air end. You might find. Move along this side. This is the business. This is the air end. All right. So we're pulling air in through the filter, which is basically, that's it. Pulls out, air is in, filtered through here, comes down through the inlet valve. It's compressed. If you think of it, you got like a sausage grinder, all right? It's going like it's spinning this way. You have two rotors. You have the male and the female rotor, and it's squeezing that air to the side. All right. Now we're injecting the coolant into the airstream to absorb the heat of compression. About 80% of its job is to absorb that heat of compression, and then the coolant and the air is discharged through the air and discharge here, travels up through this tube into the sump, which it spins, cyclonic, and a volume change. So liquids are going to precipitate out. It's recirculated up into the cooler through the thermostatic valve. If it's too cold, it bypasses, comes back down through the coolant filter, and gets injected back into the airstream. Once it gets up to temperature, the thermostatic valve opens, sends it through the cooler, comes back through the other side, mixes with the hot, comes back down through the injection hose, the return hose through the filter, and then gets injected. So that's its job, back and forth. The cooling fan's right here. No, there's nothing on top. The cooler's up on top. The airflow is going up straight. This is your fill port and your sight glass. I'll put these back together in a second. Right, so your sight glass is right here. Coolant should be up to the top of the sight glass.
Should be to the top.
Should be, when it's like this, it should be up to the top of the sight glass. when it's running, you might not see anything in the sight glass because it's doing the spinning thing and it's pulling it out and all that stuff. Your drain port on the bottom. This is your minimum pressure check valve. So air is being discharged through here. The reason why it's called minimum pressure check valve is it takes about 60 pounds of pressure to lift the piston off the seat and allow air to flow up through the aftercooler and then down into your dryer and then into your system. Right? That's your system. All right. These are your separator elements. All right. So this is where, once it's done doing its thing here, the liquid coolant is separated out. You're left with air and aerosol coolant. When I say coolant, it's not an oil. It's a polyglycol. It's coming up through here, and what it's doing is going in. It's penetrating these filters. Think of these as a coalescing filter.
Right.
You got that aerosol molecule of coolant that's penetrating. And what is it? It's starting to coalesce around those fibers as it's penetrating, so by the time it gets to the inside, it's a drop. Inside here is a stem, and it's actually a stem within a stem. All right? So it hits that inner stem, it slides down it, and it goes between those two stems, and then it's pulled back in through this scavenge system, and it goes back into the air end. All right, so it's pulling that coolant back out. Air goes down through, comes out through the minimum pressure, and then through your aftercooler. All right. Those are these are 2,000 hour. Here's your coolant filter, and if you look at it, all right. So this is the back side of it. Low. Transformer, this is what's going to convert your 480 to 230 volt to power the
Problems with the heat?
no.
Here? No?
There's so much airflow across
Okay. So it keeps the transformer cool too, it's by default.
Oh yeah, that's the whole thing. This is the new generation dryers on these things, because the original cabinet TAS, the total air system that we had, didn't have a fan on it. It relied solely on a blower. These has its own fan, so when this shuts off, this keeps going in order to pump it down, so it doesn't burn itself out.
Is that refrigerant? So you have the 410A or something in there?
That has R134A. That's what I read on the sticker. The package discharge, this is what's coming out, goes into your receiver. This is the condensate drain right here. I mean, you could sit here and watch, just make sure that it discharges. You're definitely going to want to make sure that is discharging. You don't want it to fill up. I mean, that's pretty much it in a nutshell. I mean, we can starter kit. I had to keep this on because we got power going through it.
Yeah.
I know they're rectifying the problem with the disconnect switches. Should have disconnects on both of these. They have one. They are redoing it.
That was brilliant. I know. Yeah.
All right. But they're inside of here. Kind of dirt, dust from getting in the cabinet. I mean, it's going to prolong it. It's not going to stop it. It is going to prolong it.
Pretty much.
The number one problem with this getting dirty is overheat.
There's no lead lag.
Well, you can do that. What you do is, like I said, this one's set for 100. You can set this up for 90 and 100. This is 100 and 110. So if it should drop down, to 90, at least it's going to get you back. I don't know what your target pressures are supposed to be. So I just picked an arbitrary one. You guys might want 120 psi. I don't know. So you do have your keys are right here. Do a startup on this one.
That's full speed pretty much?
We're at 100% right now.
Yeah, that's quiet.
You notice that you're in the green for your dryer. So we know that that's working. you don't know what's going to happen here, you know, until the building gets occupied. You might find out that this is going to run at 100%, and then this one might have to come on and run at 25%. Who knows? And then you might want to switch them. Let this one run 100%. In that case, you know, that's all you can do. We're up to 90 psi.
So is that a high point and then a low point or something?
You set the target and then you set the auto stop. And what's going to happen is no one's using any air. This is going to hit, you'll see when it hits 100, you're going to start seeing it drop. And then it's going to drop to about 25%. DDV just kicked in. All right, you get that off. Only running 30%. So, I mean, if it's 369, it's like a 10 horsepower. And that's the beauty of this unit. It's you're paying for a 10 horsepower compressor, not a 30. That's what that percentage. That's where this is going to come into play. See it once I get that. All right, so we go back to this one. We say, okay, we set up. Okay, now we want to set. We go to the 100 on this one. All right, and verify that the 110 came up with it. Then you can go over to this one that's still running. This one hasn't kicked in yet. You go to this one, then you can lower this down to 90. That's going to bring that 110 down to 100. It's always a 10-pound differential.
Right. They're wired to do that now. They're wired to run lead lag if we wanted to.
No, there's no wire here. You're doing it by pressure only.
Oh, I see.
There is no lead lag.
It drops.
You don't have a sequencer
I got you.
installed on it.
Okay.
So now this is going to shut off.
But you don't think you would need to do that for this building, or one of them is going to keep up on its own?
What's going to happen? It's going to try and maintain that 100. That's why maybe it might be better to do the 95 and 105. So if it can't keep up with that 100, and say, you know, it's running 100%, but it keeps on coming back down, if it's 95, this one's going to kick on.
Problem is, though, you're going to get a lot of runtime on this one, you're going to get no runtime on
Well, that's why you have to come up here and change them weekly or monthly or every 2 weeks or something like that. I mean, that's something you don't do not neglect these things.
No, what I'm saying,
Don't
this
leave
is
them
100,
without checking
this is
them
100,
because
this is
that'll
100.
come back to bite.
Table. They're not wired together to run lead lag. You turn it off pressure. We can do it automatic.
You hear the blower still running, right? That's to keep it on, make sure everything's cool.
But it's based off
Trying to make sure that your dryer is
Oh, I know. It's not wired.
pressurized, so it doesn't try and restart after, you know, under pressure.
You don't want it to. Just have if he were to press the off button normally right now, would it go off or would it wait until it was cool?
You have to wire them together to do lead lag.
Why would you never run this one?
You're not going to run me anymore? Okay, I'm done.
You just explain how it works.
I didn't know if they had like a certain time they had to shut down for.
No, it has its own, like, if this was running at 100% and I hit that button, it's going to blow down and then, you know, it'll depressurize itself and then it'll just shut down.
Okay.
No, you can't, no, this, if you hit it, it's just going to stop.
Everything.
That's why I said you do that only if there's like, you know, there, like something exploded or something like that, and you got to shut it off quick because you do run the possibility of coolant, you know, coming back up through the inlet, making a mess someplace. But the way they have the filters now, you have that really high arc, and then it comes back down. You might fill up the tube a little bit, but then it'll go right back down into the. You might get a little bit of a coolant mess, you know, oozing out someplace, but for the most part, it'll be pretty clean. But you want to make sure that you turn it off the right way.
Is there a way to wire the two so that they automatically monitor lead lag, or do you have to do it by changing the pressure difference?
That's the only way that you can do it on these units is pressure. The only way that you'd be able to have them linked together is if you went with an X8i sequencer. And install some added hardware, then it would communicate.
You don't have now.
But maybe Siemens does have that. Did Denton say yes or no?
So you're saying that if we wanted to rotate which one runs longer, we'd have to change the pressure set
settings, yes.
You'd have to come up here to do that.
Yes.
But you could
Well, you
leave
should
one-
be up
you
here
could leave one-
anyhow. You should be coming up here on a regular basis.
But you
checking.
could leave one at 100 and you can leave the other one at 100 and Siemens can just enable and disable them based on, every 7 days this one runs, every 7 days this one runs.
If you want to just, you mean leave them off?
Correct.
Leave one of them off?
Correct, they're sized for 100% redundancy, so you should only have one running anyways.
But if something happens to one, let's say that you blew a fuse or something went down, right, you didn't come up here and check them and it
Right,
got
so
low
pressure,
cool.
right, so pressure goes down and you kick the second one on, you enable both of them when you get a pressure alarm or something.
Well, how are you doing that?
We got pressure transducers.
Yeah, but they're tied together. They're seeing the common line.
Right, but if any of them go into an alarm, which means it gets below its set point,
Yeah,
then you kick it, you
how's
enable
it go-
both of them.
Sitting right there, how's it going to know? This is a common line.
Right, but you're going to lose pressure in the whole common line, right? When one goes down?
Yeah, then
so we're just going
someone's
to
gotta
enable the
come here and
second
turn
one, so the
on.
second one's just going to kick up and
He's not saying.
this one's up and running, you blow a fuse, it goes down, it's completely down. This pressure transducer and this pressure transducer, they're really the same thing right there, going to alarm. Same with below.
Well, I see if you're saying that this wasn't on, but we're saying to keep this on at a lower pressure so it's ready to go in case something happens.
Right, but then he's got to come up here and manually switch it back and forth.
Not necessarily, because you'd be running at a lower pressure. Yes, that should be. Well, this should have the alarm context. You should be getting an alarm someplace wherever you're monitoring.
Right, we do. Right.
All right.
Can we
so
touch-
you know that there's a problem, but you haven't lost house air because this one kicked on automatically.
Right. I was saying disable one and enable one. Right. Can we?